Hello everyone. Today in this video we're going to discuss about a problem uh, that is sliding window maximum. Okay, so this is 239th problem of Leetcode. Okay, so we will see the problem statement first. Okay, so given an integer array nums and an integer k, return an array representing the maximum value in every contiguous subarray. So what does this mean, guys? Okay, so if you say k is the size, okay, so we need to consider a window of size k, so that means 3, so 1 2 3. So we need to find out the largest number of among these three, right? So 1 3 minus 1, so 3 is the maximum number, right? Largest number. So and then we need to slide the window, so 3 minus 1 minus 3. So from these three we have the three largest, right? And then minus 1 minus 3 5, so we have, in this case we have the 5 largest. And then minus 3 5 3, we have the 5 largest. 5 3 6, we have the 6 largest. 3 6 7, we have the 7 largest. So if you see, this is the output. So what this is what we need to find out, right? So which is the largest number, or the maximum uh, maximum biggest number among the three. Okay, so we will go to the program. The problem is, when you try to simulate with these big number, okay, this is a huge number, 1 2 3 4 5 6 7 8. So if you simulate for each number, then this is really tedious work, right? So what we will do, we will try to take a small input, and then we will try to find it, and if possible we will go for the biggest number, largest number, right? So this is the program. So we will try to simulate it. Okay, uh, okay, so here is the program, guys. Be patient. Okay, we need to be patient to do this kind of work. Okay, this is really tedious work. So nums, this is the array. So what we need to do, we will just try to uh, find at least one. Okay, 1 2 and 3. So these are the three we will find, but if possible we will go for the largest biggest output, right? Big output. So nums 1 2 3 k equals 3, return size, and then we will have to you know we know that we will have to return an array, right? So when you return an array, we can't declare like this, okay, result. So we have to provide this asterisk. This is for the pointer. Okay, so now we will not consider this one. We will go to the max sliding window, right? So here, if you want to have a look, then before max sliding window we have something, right? So let's see, we have a data structure. This is like this is a data structure. This whole thing is a data structure. It's not like uh, function, right? So this is a custom data structure. We just defined it. In this data structure we have a data pointer, okay, to integer, and then three integer variable, front rear size, right? And um, this name of this is dq, initialize dq. So we have a function initialize dq, and in this dq we are you know we have something. So we will see next what it is, right? And then we have a pushback function, popback function, pop front function, front function, back function, and then we have the sliding window maximum function. So we have to start from here, but we have these things up, right? So what we are going to do is you know we will separate some functions for our convenience, right? So what we will do, pushback and popback, right? So let's say make a new file. Guys, we really need to be patient, okay? It will take maybe an hour, but we have to stick with it, right? And then another new file. uh, for these three, right? Pop back, pop prompt. So these are the two things we declared, I mean separated, right? So now we will start from the max window, max sliding window, right? So we know that now this pointer will definitely be here, because without this you can't return array, okay? So as nums is array, this will the input will this num will be a pointer to that num, okay? I hope you understand. Num size and the integer k, integer return size. Okay, so if num size is equal 0, if there is no number, and k equal or k equals 0 if there is no specific size of window, then return size would be 0 and return null, okay? Nothing to be returned. It's obvious, right? And we have to define a result. We have to define the result, and this will be num size minus k plus 1, right? So we will try to understand why num size minus k plus 1 is here, right? But for our input, let's say for our input is 1 2 3, so num size is 3. 3 minus k equals uh, 3 minus 3, right? So 0 0 plus 1, that means 1. At least one character, one space for one number should be here, right? So what we will do, we will take another file, and maybe here we will insert a table for the numbers, right? Result, right? So let's define it like res 0, and then res 1, res 2. This is how it will work, right? Res 1, so this is how res 2, this is how it will work. So we have made space for this one. Return size in the beginning, return size would be 0, right? So dq, so dq is a pointer to that dq, and we need to go to the create dq now, and nums and the size of the dq would be num size, right? So we know num size is 3 in our case. We have so we need to go to the that function, create dq. So here, and this would be 3, size is 3 now. So dq, okay, create dq malloc size of dq. So whatever the size of dq would be created, right? So dq, if you see this dq, in this dq you have data, front, rear, size, whatever the size of the whole thing, this dq would be created. You understand? This dq is a pointer to that dq. So uh, so this dq is being created, right? Okay, so now this dq's data, integer, pointer, malloc, and into size of integer. So for for 3 integer, right, dq data is created, and dq front would be 0, dq rear would be -1, dq size is 0, return dq, right? So this is the thing we are going to create here. So if you see, uh, for 3 integers it's created, okay? So we can dq data maybe 0, dq data 1 and dq data 2. This is how it will work, right? Okay, and dq front rear size return dq. So what we're going to do, we're going to make another one. dq front, let's say dq front and then dq rear and then dq, what it is, dq size, right? This, okay, dq size. So let's just define this. We're trying to visualize at as much as we can, right? So here you go. So now we were here, right? We just created this. Now we have a for loop here. Let's say first iteration, and we need to take them. So I is 0, I starts from 0, and then num size would be 3 in our case. Remove indices out of window. Okay, so if dq size greater than 0 and front dq I minus k less than or equal to I minus k, so remove index out of window if dq size greater than 0. So when we remove a number from the window, right? So dq size is greater than 0. So if we see in the beginning we have dq size, what is the dq size? Dq size was 0, rear was -1, front was 0, right? Let's see, let's just see this again. Front 0, so just put the value, guys. Okay, front 0, rear was -1, and size was 0, right? Size 0, yeah. So in this case, our if dq size is greater than 0, so dq size is not greater than 0, so this condition will be false, right? Maintain decreasing order in dq. So what does this mean, guys? If dq size is greater than 0 and nums back dq, pop back dq. Okay, so here dq says this is going to also be false, and then push back dq I. So I is 0, and then we have to go to the pushback function now, right? So if you go to the pushback function, here is the pushback function dq idx. So this is going to be 0. Idx is 0, right? So when idx is 0, so in this push dq rear plus plus. So that means rear would be increased. So what is the rear in our case? Rear is -1. So if we do plus plus, this would be 0, right? And dq data dq rear, that means dq data dq rear is 0 now. Okay, so dq data 0 equals to idx. So if we go there, if you go dq data 0, and we have to provide what? Idx. So what is idx, guys? Idx is 0, right? So here we need to put 0. Do you understand? dq size plus plus. So whatever the size of dq size plus plus, that means 1. Okay, I hope you understood. Start adding results once first window is complete. Okay, so if I greater than or equals k minus 1, so k is what, 3 minus 1, that means 2, I is only 0, so we don't have to do anything here. So this condition is false also, right? Start adding results when first window is complete. So without being, without completing 3, we cannot get this as true, right? So what we will do here, we go for the second iteration. Would be 1 here. 1 is smaller than num size. Okay, so if dq size greater than 0, so what is the size? Size is 1, right? So yes, this is greater than 0. And front dq less than or equal to I minus k. So what is I? I is 1 now. So I minus k, that means minus 2, right? And what is front dq? So let's say go to the front dq, uh, go to the front function here. So dq, okay, front dq, return dq data dq front. So what is dq front? Okay, so if you come here, front is 0, right? dq front is 0 still. So front is 0, so dq data dq front, right? So this whole thing is giving us 0, so dq data 0 is 0, right? We know that. Is it dq data 0 is 0. So 0 is not yes, 0 is less than or equal to is 0 less than or equal to minus 2, right? So 0 is not less than or equal to minus 2, so this condition will be false because this part is not true, right? So this will be false again. Maintain decreasing order in dq. So while dq size greater than 0, so yes, dq size is greater than 0, and nums back dq less than or equal to nums I. So let's go to the back dq function, right? So where is the back dq function? Here is the back dq function, dq data dq rear. So what is rear, guys? Rear is 0, right? We know that rear is 0. So when rear is 0, so dq data 0 is 0, right? So 0 is 0 less than or equal to minus 1 I. Okay, so here nums I, what is nums i's value? Nums i's value is 2, right? And value of this is finally nums 0, so back dq is giving us 0, right? So nums 0 is 1, nums I is 2. So is it less than or equal? No. uh, you know okay, so nums I, yes, it is greater than or equal. Nums I gives us 2 because I is 1, and nums back dq is giving us 0, so nums 0 is 1. So yes, this condition is true. So maybe we'll have to pop back dq. So we need to go to the pop back dq rear minus minus, dq size plus minus minus. So here we will go dq rear minus minus, so this would be minus 1 again, and this would be size would be 0 again. Okay, so now we have the pushback function again, dqi. So dqi is 1, we know. if you go to the pushback function again, so I is here is 1, dq rear plus plus, that means guys this should be 0 again. dq data dq rear, so dq rear is 0, so dq data idx is 1, so in this dq data 0 we need to put 1, right? And dq size plus plus, what was the size was 0, so we need to provide it 1. So I is 1 now, 1 is greater than or 3 minus 1, yes, this is false again, so we don't need to do anything here, right? So we need to go for the third iteration. K minus 1, so 3 minus 1 is 2, right? So we need to go for the third iteration. So here this should be 2, so 2 is okay, condition is 2, dq size greater than 0, so if you see size is 1, yes it is true. And front dq, we need to go for the front dq function again, and I minus k. So what is I, guys? I is 2 minus k, 2 minus 3 is equal to minus 1, right? So let's go for the front dq function. This is front dq, so front dq, dq front dq, so what is dq front? Okay, so if you see dq front is 0, right? dq front didn't increase, so dq data dq front, so what is the value of dq front is 0, so dq data dq 0 is 1, right? We have the value 1 now, so here we are getting 1, and here I minus k. So what is is 1 less than minus 1? No, right? So this condition is going to be false again. Okay, so dq size is greater than 0, this is right. Nums back dq nums I, so this nums I will give us 3, right? So what is back dq is giving us? If you come here, back dq data dq rear, so what is dq rear? Dq rear is 0, so when dq rear is 0, so in 0th, okay, so dq rear is 0, right? So dq data 0 is, we know that value is this 1, right? In dq data 0 we have the value 1, so nums 1 will give us 2, so 2 is less than 3 or equal to, fine, this is true. So now we have to do pop back. Okay, so let's go to the pop back function. We know that this is really tedious work, but we need to do it. So now rear minus minus again, size minus minus, that means guys rear would be minus 1 again, and s would be this would be 0 again, right? So now pushback, so let's go for the pushback function. Here you see idx would be 2, okay, so rear plus plus, that means guys rear would be 0 again, and dq rear so 2 is here, right? dq rear would be 0, so dq data dq idx, so dq data 0 equals idx, that means 2, so in dq data 0 we have to provide 2, right? So now we need to check start adding results once first window is complete. So if I greater than or equal k minus 1, so 3 minus 1 is 2, so this is not greater at least, but it is equals, right? So this false would be true now. So result return size, in the result return size is 0, right? So we know that return size is 0, so in this place in zeroth place, result 0, we need to nums front dq. So what is front dq giving us, guys? So if we go here, front dq data, dq front. So dq front is, so we know that front is still 0, right? Dq front is 0. So in dq data 0, we have the position 2, right? So we have the value 2. So if you so this front dq is giving us 2. So nums 2, we know that what is the value in nums 2 position, 1 2 3. So 3 would come here. So now return size plus plus, now return size will be 1. You understand? So so doing, uh, all the operations in 3 numbers, we get the 3 is the biggest number among them. So if we want, we can take a bigger, larger number, right? And then uh, simulate the program step by step, right? So now we have to free dq data, free dq return result. So I hope you got an idea how the things work, guys. Okay, so finally in the result 0, we have to put 3, and we need to the program will return this 3, right? So I hope you just got an idea about how things work. So after the maximum sliding window, we have the print option. Output would for this bracket would here come here, and then I hope I don't have to uh, give you a clear idea about this thing as well. Okay, so I hope you at least got an idea how the things work, right? So now we will try to simulate the program for a bigger number, right? So stay with me, guys. This is going to be a tough work, but we have to do it, right? So maybe in the next session I will do it. Thank you for watching. See you in the next. Okay.